All right, welcome to the video on what are patterns and what about sequences. So in this discussion, we're going to talk about a couple main things that lead into a lot of algebraic concepts. Now, it's important to understand that math is really just a study of patterns. We find a set of numbers, in this case, these are a sequence of numbers, and we try to find a pattern. Now, we can also do patterns are associated with, let's say, a box, and you see maybe a two-sided figure, a three-sided figure, four-sided figure, so on and so forth. And so you can find patterns within a lot of things, all right? Also, there's like a pattern of if you wake up late, you're generally tired. And every day you wake up late, you're generally tired, and you generally kind of change your pattern, all right? Pattern of sleep. But if we were talking more in a math sense, we talk about sequences. So here's two types of sequences that we're going to discuss in our math class. We have the arithmetic sequence, which talks about a common difference, and we also have a geometric sequence, which talks about a common ratio. Now, in both cases, I've given examples here of a arithmetic sequence and a geometric sequence. So you'll notice that in the arithmetic sequence, we have a set of numbers here that go up by a certain number, or we call the common difference. So that, in this case, is, if you notice, it would be plus 4, plus 4, plus 4. And then, by just the pure idea of what the pattern or sequence is telling us, we can guess the next term in the sequence, which is 11. Okay. Now, as we move further into this unit and into this concept, we're going to start writing the actual expression these sequence of numbers come from. But that's down the way for us, and what a lot of people in math use to predict the future. If you have a pattern of events or a pattern of numbers, statistics, we try to decide what's going to happen in the future based on that. But I think I'm getting a little ahead of myself here. We got to get back to just the basic stuff, which is arithmetic and geometric sequences. And so if we look at this next pattern here, we notice, all right, the first thing we kind of see is that, all right, it's going up, or it's by subtracting 5 each time. All right, so if I were attacking this problem, let's say I wanted to look at, well, I need to determine whether it's arithmetic or geometric. So my first thing I would do would be to, well, it's subtracting 5, or we're multiplying by 2. So that's what happens in between the first two terms in this sequence. Now, to check which one it is, I can then go to my second to third term in the sequence, which is, in this case, we subtracted 10 and we multiplied by 2. Now, based on this, we notice that the common difference does not apply here because we're not adding or subtracting by the same number. And so the only thing left is to determine whether it's geometric, and we look at our next term in the sequence and we notice we're multiplying by 2. So therefore, based on the evidence we have of this sequence, nothing to steer us wrong or in another direction, we would call this a geometric sequence with a common ratio of 2 or times 2. We're multiplying by 2 each time. So if we wanted to, we could guess the next term in the sequence would be negative 80. Now, in your problem set that you will get to work on in your groups, it's going to ask for what for each sequence. Say if it's arithmetic, geometric, or neither. Then write the next term in the sequence. Right. So next term in the sequence. I might ask you to do the next 3 terms in the sequence, but for practice here, we'll just talk about the next term. So on this particular one, we first look at how you attack these problems is that we first look at the common difference. Now in this case, it looks like the common difference is between the first and second term is plus 1.5. Okay, then in the next one, or now if I look at it from a geometric standpoint, I see that I'm multiplying by 4. Okay, that's times 4. Sorry, let me correct that. It's not 0.4, it's times 4 with a dot. All right. So these are the two patterns I noticed between the first and second term. I'm either adding 1.5 or I'm multiplying by 4. So then I go to my second and third term. Now I noticed that if I were to add 1.5, I would get 3.5. So that means that my arithmetic sequence opportunity or the common difference is gone. So now I determine, well, does my times 4 still hold up? Well, if I take 2 times what? That'd be times 4. And then you'll notice that, yes, that pattern continues on. So I'm able to determine, based on the evidence I'm giving of the sequence, that it is geometric and the common ratio is times 4. Okay, geometric. That's a bad looking geometric word there, but we'll go with it. All right, so the next one. Let's look at this next sequence of numbers. So from the first term to the next term, it goes up by 30. All right. Now, for geometric, I look at this and I'm like, there's no real natural number or integer that I can multiply negative 7 by to get 23. So I'm just going to say, I'm going to see if this 30 works, and then if it doesn't, then I'm going to look at that geometric idea, or what I multiply negative 7 by to get 23. So I look at this next one, so I notice this is also adding 30. This is also adding 30. All right, so we see it's a common difference. So we're going to say arithmetic. I know it looks like it is spelled the same as arithmetic. We're going to use arithmetic sequence. And then for my next one, so the next term in the sequence, if we add 30 to 113, we get 142. All right, let's look at this next one here. Okay, if we look at here, we notice that it goes subtracts 4.5. All right, so that's one thing that's happening, correct? If I'm right in my assumption there. Let's see, if we were to add 4.5, we would get that. So if we're subtracting 4.5, and then we notice, all right, well, what is it dividing by each time? Well, or multiplying by in this case. Let's say it's multiplying by negative 2. We took 1.5 times negative 2 to get negative 3. So again, I look at my, that's the first and second term. That's the difference and the common ratio. So then I look at the next one and I notice that, all right, well, probably the 4.5 is out of the picture because this have to be negative 7.5. But then I notice that negative 3 times negative 2 is 6. So that's still holding up in my sequence. And the next one I notice is times negative 2. And the next one is times negative 2. And so my common difference is common ratio is multiplying by negative 2. And my next term in the sequence would be negative 48. Okay? Now on this one, 24 here, we see fractions there. It's okay. It's all right. Notice to solve this problem, what I would recommend doing is to have them all have common denominators. If we all have a common denominator, then it would be easier to figure out the sequence of the numerators. So if you are ever given a problem where the sequence is fractions, try to make them all a common denominator and then see what that possible pattern is in the numerators. Okay, so we're going to go over this one in class together, and also threw in an extra problem here, and to see if you can find out the next 3 terms in the sequence. It also has a name, and you'll notice in this particular case, it is neither a arithmetic or geometric sequence, and that is possible. We can have sequences that don't fall into those categories, but see if you can discover the next 3 terms in the sequence and also give the name for it. All right. Thank you very much for listening, and please email with any questions. Thank you.